and change my recording view to speaker. And I'm going to introduce Julio and then stop talking. We're happy to have Julio Barros here with us. Steve and I met Julio back in May when we attended a lunch and learn at University of North Carolina, Asheville. And during that day's events, we got to learn from Julio. He provided a really great introduction for folks who are just learning about AI. And since then, he's been involved with a couple other presentations that Steve's been a part of. And so we asked him to come and talk with us and, share with us his insights, as well as, just give us a really good primer on what AI is looking like today, how it's being used today. Julio is a business owner in the area. He is a programmer turned AI consultant. How do you like that, Steve? We just came up with it. And he's actually going to be traveling to Boston next week for the Generative AI conference, where he's going to serve as an AI advisor for the conference. So he's going to be hearing about things and providing some advisement on next steps and directions that individuals or groups or organizations can go with the potential for AI. So with all that, I'm going to stop talking and say thank you again to Julio and turn it over to him.
All right, great. Thank you. And thanks everybody for coming here. I am really excited and honored to be here. Thank you to Sarah and Steve for inviting me. Let me share my screen. There we go. And like we said, we are, I'm going to talk about, give an introduction to AI and then talk about all this, let me arrange all these screens. All this hype we've been hearing about AI and generative AI and where things are going and what people are doing with it. And I have a lot of info, so I'm going to try to talk, get through a lot of this. We'll have questions at the end. Feel free to post questions in the chat, and then Sarah will collect and curate them, and she'll stop me if there's something really that we need to address right away. What I want to do is give an intro to machine learning, AI, and generative AI. Talk about some use cases, and then talk about some risks and some challenges, and then go to the conclusions. Like Sarah mentioned, I'm a consultant, a machine learning and data science and AI consultant. I've been doing that for many, many years. I got a bachelor's in computer science from George Mason University up in Virginia. And what drew me to computers back then was AI. I kind of didn't even know that at that point, but I was very interested in kind of almost the philosophical side of it, like trying to understand what learning was, what it means to think, what it means to compute, how we can get to abstract concepts and somehow combine them and come up with something else. And then I ended up taking kind of the computational angle on that. So that's what led me down AI and computer science. Then I worked on my master. I got my master's from in computer science and AI at the University of Virginia, and worked on my PhD for a little while, but I didn't finish my PhD. Anyway, so I am new-ish to the area. I've been here about a year, but lived all over. That's what I do. So the first question I want to start with is like, what is AI? And then this is the definition from Wikipedia. And they say it's the ability of machines to perform tasks like humans, such as learning and problem solving. I want to change that a little bit and say that it's really the area of focus, the area of study where we're focusing on systems that can adapt, learn, and reason, and make good decisions, even with ambiguous, uncertain, incomplete, wrong data, and even when faced with unsolvable problems. Unsolvable means intractable. And the idea is that some problems we have a formula for, we have the steps for, we can go through the steps so we can solve them. Like if you have a list of numbers, it's pretty straightforward to add them up. It's pretty straightforward to get the mean of them or something like that. But there are other problems that get harder and harder, and we really don't have a good way to solving them, or we don't have enough information, or the information can be wrong or incomplete.
Hey, Julio, just to give you quick feedback, right now, the right edge of your screen is not visible to us. So we're getting cut off on your, there you go. Perfect.
Okay,
Thank you.
Thank you. So the term AI started a long time ago. I didn't want to get into the history of that, but at first there were things like tic-tac-toe, trying to get a computer to play tic-tac-toe in a way where we didn't explicitly explain all the different steps was AI. That was solved pretty quickly because there are only like 9 squares and it's a very limited number of moves you can make in tic-tac-toe. So then people said, well, that's not AI. Chess is AI. Chess has 64 squares, I think 32 different pieces, and they all move in different ways. So that space that you can explore is much more complicated. You can come up with rules of thumb and heuristics about what you can do to play chess, but to really get really good, we ended up using different kinds of machine learning to analyze the games and to make the best decision possible given a particular board's configuration. It may not be the optimal move, and the chess programs don't always win, but then that starts to be more something we can call AI. There's an old rule, an old joke that as soon as something works, it's not AI. So chess was on that edge up until recently. The game Go was on that edge. That has even more positions, so even more boards. The stones are simpler, like so the pieces are simpler and the moves are simpler, but there are so many more of them that they're hard to, that you can't really compute them all. You can't solve that game. People used to think that things like maybe recognizing spoken language or transcribing audio would be AI, but we can do that now. Writing a poem, we have AI that does that now, create music and so on. So these are all things that were AI in the past. Maybe they're not AI now. The term and the definition changes over time. A lot of examples for AI with that in mind are things like getting routes, like everyday examples for today. We have things like getting routes on a map. If you needed to go to New York from wherever you are, there are lots of different ways to get there. It's hard to know what the best way is, but you want the system to give you a good way. And it can depend, a good way can depend also on constraints you might have. You might need to make certain stops along the way. You might decide that you don't want freeways or highways, that you want a more scenic route. You might decide that the shortest distance is preferable versus the shortest time, which can be different things. It might also depend on things like the weather and the time of day and the day of the week and things like that. So all those things will go into making a decision about what a good route might be. Other things like that are weather forecasting. Everybody likes to complain about the weathermen and how the forecast is always wrong and everything. But without weather forecasting, we wouldn't know a lot of things. Like there's a hurricane off in the Atlantic that is probably going to veer off the coast, but we don't know. So that AI analyzing a bunch of data in a really big system is part of examples today. We have things like spam, email spam, that's done really well. Fraud detection, personalized recommendations. We can complain about those too, like, oh, I just bought a vacuum cleaner. Why do you keep recommending vacuum cleaners? But a lot of times, often that times that does work well and gives you pretty good suggestions for what you might want. Photo tagging, I'm sure we all have phones. I love when my phone tells me, makes up a little album of like my loved ones and throughout the years or whatever, and the times I've visited Charlottesville or whatever. Grammar checkers, text autocomplete is a kind of AI. In particular, text autocomplete is important because when we're talking about generative AI, and one of the AIs we're going to talk about today, that you can really think of them as really souped up text autocompletes. So in summary, like AI is an overarching field that includes many subcategories. It includes machine learning, which is where you look at a bunch of data and then you learn, the program learns something from that data. So it's not programmed explicitly by a human being. And then a kind of machine learning is deep learning. We've heard of neural nets and things like that. That's all part of that. If we do this on text, we might call it natural language processing. If we do it on images, we might call it computer vision. Other fields that are included in the AI field are things like knowledge representation. So now that you know something, how do you represent it? How do you manipulate it? How do you process it to do something else? The idea of reasoning and the idea of doing symbolic logic on those facts, on that representation once you have it. Things like expert systems and rule systems are part of AI. Search, optimization, and planning. That's all part of the AI, and that's like a big part of the routing thing, with like a lot of different routes between two different places, and you want to search for the best one or optimize one. Planning is a big part of it. There are different simulation kind of algorithms, like the Bayesian or probabilistic things, genetic algorithms, agent-based modeling. So all that stuff I think falls under AI. Another maybe simpler way to think about it is there's a continuum between AI, analytics, machine learning, and AI. And we can say things are descriptive, and that's very statistical. That might be your traditional business kind of business info, business statistics, where you might want to say like how many things did I sell last year, or how many students registered for this class, or whatever. That tells you about things that happened in the past. They're facts about the past. You could then move on to maybe more machine learning, which is more predictive, which might tell you how many things will I sell tomorrow, how many students will register for this, given that it's the fall semester, given that I've got this many freshmen coming in, given that I have all these other things. Prescriptive analytics and machine learning might, and the predictive stuff really deals a lot with correlations. So a big mistake people make is they try to make those correlations causations, but you got to be aware about that. Yeah. Prescriptive stuff starts to touch on the causation of it. You say, well, what can I do to increase registrations? Or if I make this change, what will happen to this thing I care about? A lot of these types of systems are based on models that you build and use a lot of human knowledge or experience to kind of come up with not a formula, but a different way of representing the situation. And then as you manipulate it, you can see what the output is. And then what's become really popular, what's getting a lot of hype lately, is the generative stuff. And the idea here is that you create a system that learns the structure of the problem you're looking at, and then you can then use that structure to generate new things like that old thing. And we'll talk a little bit more about that. But these are different kinds of well, this is maybe the spectrum between analytics, machine learning, and AI, and then generative AI. So a generative AI system really learns the representation, kind of the structure of some data. So that could be text, it could be an image, it could be a database, a bunch of records in a database. And then it uses that structure to either find similar things, so you find similar sentences, or sentences or paragraphs that talk about similar things, or you can use it to create new things. So you can use it to create new text, you can use it to create new images, you can use it to create new students or a new audience that look like the audience that you trained the system on. An important thing to really keep in mind is that these generative AI systems, they're not knowledge bases, they're not databases, and we're gonna want to treat them like they are, and we're gonna ask questions, and we want facts, but they're not. They're just statistical representation of the structure of that information it was trained on. The really interesting thing is that statistical representation can be really, really useful for a lot of things, and it can lead to a lot of emergent behaviors, and the systems can then start behaving like if they know a lot more than what's really there. And it can be really useful in a lot of cases, but they're not knowledge systems, they're not fact-based systems. Okay. The generative AI system that's getting a lot of hype is ChatGPT. And the idea with ChatGPT is you type in some text, usually a question, and then it answers you. But all it's doing is really doing really intelligent or really advanced autocomplete. It doesn't really know a lot of well, we can't get into like what it means to know something, because that would take like hours and days and years, and people have been discussing that forever. But it's amazing that the idea of it being trained to predict the next word can lead to it generating fluent sentences, and that these sentences we can then find useful and get a lot of meaning out of. So I'm going to harp on it a bunch. Is like maybe asking for facts is not the best use of this kind of technology, but maybe asking it to do things or to process text might be really useful. So in ChatGPT, I said, what are some interesting titles for courses that introduce AI to college freshmen in the Blue Ridge area, in the Asheville area? And it came up with a bunch of ideas. You might think they're great, you might think they're kind of not so great or whatever, but the idea is that it came up with some ideas, and then it gives you a starting point, and you can refine those ideas yourself. You can just take that text and go do something else, or you can then ask ChatGPT to refine the ideas and say, no, I want funnier ones, or no, I want serious ones, or I want whatever. Or I love the ecology angle. Give me more about ecology or whatever. So that idea of working with the system to have it generate ideas for you is a really powerful way to use these kinds of systems. And again, I want to point out it's easier to critique, edit, rewrite things than it is to start them out. So it's fantastic for like when you don't know what you want to do. This will give you a great starting point for a lot of things. So that was ChatGPT. I want to go over the vocabulary a little bit. So ChatGPT is a product. It was a chatbot created by a company called OpenAI. Chat means that it maintains conversational context, which is in contrast to question and answering systems. So it's like built on top of question and answering. A Q&A system might answer your question, but then completely forget what you're talking about. But the idea with a chat system is that it keeps some kind of context of what you're just asking it. And so you can ask it to refine itself. You can ask it to clarify itself. You can ask it for more questions. You can ask it for more answers and so on. GPT was a general kind of technical abbreviation. OpenAI is trying to make it a trademark or something now, but it stood for Generative Pre-trained Transformer. Generative means it can be used to generate things. Pre-trained means that it was trained on a large corpus of text, and then it'll be fine-tuned on a smaller corpus for a particular use case. So when trained it on a large corpus, corpora, I guess is the right word, it learned a lot about the structure of language, and then you can fine tune it to make it do other things that you like, something else, a specific task that you might want. And transformer is a technical architecture for the kind of neural net that is used in these models. So that's what GPT means. So a lot of people now, they're trying to trademark it, or we're trying to trademark it, but a lot of people add GPT to whatever it is they're doing to kind of make it, to let you know that this is the kind of thing they're doing. Another word you might hear, or another abbreviation you might hear, is LLM, which is large language model. Language model is just a machine learning model that has learned about language, and the large language model is a machine learning model that has learned on a lot of language. So these companies or these organizations, they scrape large parts of the internet. They use all kinds of books, all kinds of texts that they find or that they can get, that they have access to, and they train the language model on that text so that it learns a lot about different kinds of uses for different ways people use language. And there are lots of LLMs. So ChatGPT is the most famous one now, but another really useful one is Claude from Anthropic. Google has Palm, and they've released another set of models now that is being integrated into their systems. And there are open source models. One of the big famous ones now is called Llama, which was released by Meta/Facebook. And so you could, with the right technology and the right people and everything, run this model yourself on your own computers and with privacy, and you can retrain it on your own data. You can do this by starting with this open source model that has already been pre-trained on a bunch of text. And people have done stuff like that for specific domains. So Bloomberg has a model that has an LLM they call Bloomberg GPT, which was trained on all the financial data and the articles that they have amassed and written for the last 50 years or however long they've been in business. There are similar things for medical data. There are similar things for all kinds of different specialized domains out there. There are other kinds of generative models, but like ChatGPT is like the big one that gets a lot of hype now. So that's one we're going to focus on or talk about today. But the kinds of models that generate images and things, those are usually not LLMs, because that's large languages, but they're diffusion models or GANs or probabilistic networks and so on. So there are other architectures out there. And chat is not the only interface. You can use an LLM, and instead of training it on English, you could train it on computer programs, and then it'll help people write other computer programs. And this is kind of like the sleeper use case for LLMs today. I don't know, a lot of programmers don't like using them because the answers of the code it generates isn't always exactly right, but it's usually really, really close. And I believe it really makes programming much, much more efficient. And so I think many programmers are using it, and it's really improving the productivity of programmers everywhere when they use this. And that's probably the most commonly used language model out there, I think, is this like a coding assistant from GitHub, and there are a couple of others out there. Microsoft is adding, so this is just, chat's not the only interface. Microsoft is adding a bunch of LLMs that they're calling Copilot in general as a brand, to Word, to Excel, to all their other, to their mail tools and stuff like that, to help you generate email responses and do all that kind of thing. Google is doing the same thing. They're calling their product Duet, and they're going to do that for email and for everything. So you can have these systems kind of doing intelligent things for you without having to go to the ChatGPT browser window and typing it in and so on. And a lot of these systems also have a way that you can talk to them with a computer program. So you can use an API, an application programming interface, and have write a simple program yourself, or use a spreadsheet or something. Sometimes they can hit API endpoints, or have a developer create a specialized program that does whatever it is you want to do. So you could query a bunch of records from a database, and then for each one of those, run a particular query or question on, submit a particular question to the LLM, and then do something with the answer that comes out of it. So AI and generative AI is being integrated into everything these days, and there's a big difference. There's a little bit of distinction right now between applications that are just AI and then applications that we've been using forever that are adding more and more AI. But I think they're going to be introduced to every traditional application, every traditional product out there. Some use cases we saw, ChatGPT and using it for text. There are a bunch of image generation tools where you could type in, give me a silhouette of a cat, and it'll generate a picture of a cat for you. There are ones where you can manipulate and change existing images. So you can take the sunflowers and change them to roses. And then there are ones that let you change or alter an image, changing the style kind of. So saying this, give me this regular bedroom and make it look like it's something else, or change the style of it. And there are all kinds of image related things like that. There are not LLMs, there are generative tools for creating music. So now you can say, hey, I want jazzy lo-fi music to study by, and it'll generate some music for you. Energetic fanfare music for introduction to a video or something like that, and it'll generate that music for you. It may or may not be the best music, but it's a place to start, of course. There are all kinds of other examples. For medicine, of course, we've always done imaging and traditional machine learning for detecting cancers or detecting tumors or detecting things in x-rays and things. But now you can use generative AI for things like drug discovery, personalized medicine, all kinds of things like that. We can take audio of spoken language and create transcriptions, which could be great for classes or sales calls or just transcribing meetings. You can translate from text or audio from one language into another language. So you can take spoken Japanese and translate it to French or something like that. That's all possible today. You can summarize these transcriptions. You can summarize papers. You can summarize articles and things like that. You can classify text, which I think is really useful business case, where you have customer reviews. You can classify them as positive or negative, or important or not important, or emergency, I need to respond to this user right away. Use sentiment analysis. That's kind of like sentiment analysis. You can extract information from these things, like what is it that they love about this product or class or whatever. What is it they hate? Do that all, analyze that all automatically. And you can start doing some crazy things like doing text to 3D objects. So this was a model where you can say, make me a chair that looks like an avocado. And it comes up with this really simple little avocado chair, or make me a plane that looks like a banana. Now, right now, they're kind of toys. Maybe they're useful for brainstorming or for generating kids' toys or something like that. But this is only going to get better, and you'll be able to say, design me a house that's a single level house or whatever, and it'll do that kind of thing for you one day. Right now, you can do these simple toy things. The way a lot of these things work is that they take whatever your input was, your input data, the text, an image, or whatever, they run it through a model that gives you the statistical kind of representation of it, this encoding, or you might hear the word embedding. They take that embedding, that encoding, manipulate it somehow, and then take the resulting embedding and then run it through a decoder to get back out some particular data. So you can do text to text. You can input a bunch of text, encode it, and then decode it as a little bit of text, and that's summarization. You can do a bunch of text in English, encode it, decode the meaning into French or something like that. And you can do things like take a bunch of text, encode it, and then decode it, but make it into an image or a 3D model or whatever. So this whole process is what this is a high-level conceptual diagram of what these models are doing. I bring this up because I think we can do even some much more interesting things, like including with healthcare. These are, this example on the left is a paper where they took a volunteer, put them in an fMRI, which is those big machines that you lay down and they slide you in, took the signal out of the fMRI, showed the volunteer an image, and that's the image on the top row, like this teddy bear, took the signal out of the fMRI, and then we're able to decode it into another image. So it's not exactly the same teddy bear, but you can see at the bottom is a teddy bear, and that this is a tree-lined walkway, and so they were able to decode a tree-lined walkway. They showed an airplane, they were able to decode an airplane. I think that was amazing when I saw that. It can feel a little creepy that they're reading your mind, but right now, you need to volunteer, you need to be put into an fMRI for them to do this, and it's not perfect or anything like that. But this same kind of technology can then be used for this story on the right, where they were able to give this woman who had a stroke and was paralyzed and couldn't speak or move her face, I don't think very much. With an implant, they were then able to decode her brain signals so they could give her an avatar that was able to speak her thoughts, right? So I think like that's a lot less creepy and really, really a cool use of it, right? With this type of thing, we'll be able to give one day people the ability to speak, to control prosthetics, things like that. So this idea of encoding and decoding everything. And I am going long, oh my goodness. This is really crazy and out there, but I thought about not putting it in, but you could probably use the same kind of technique to decode things like animal sounds. Now, animals probably don't have a sophisticated language as we do, but if you believe that they do have some language, there's probably no reason why we can't take basic animal sounds, encode them, and then decode them into an English sound, so we have some idea of what they're saying. So whales, dolphins, dogs. I know my dog whines in a particular way when he's hungry, so I know what it is, but maybe we can decode some animals. All right. Along with good uses like the brain reading thing, we have things like AI and law. The story on the left is the story of a man in Ohio who built a shed and then in his backyard, and he thought he was within the zoning rules. Some zoning commissioner came by and gave him a ticket, and he didn't like that, so he went down to the zoning office and asked why. Was trying to figure out what he needed to do. Things didn't work out. Things escalated from there, and he ended up getting a criminal citation for this shed. And so then he wanted to fight it. If you wanted to fight something, if you want to fight a court battle, if you want to, typically maybe need to hire a lawyer. That can be really expensive, and this is just a shed, so it really wasn't worth it. But he was able to use ChatGPT to figure out what the process was, what the laws were, what the zoning regulations were, and what he needed to write to submit to the court so that to submit the correct motions to the court, and then the court was then decided to drop the charges against him. So that's a successful use case of using this kind of technology to do something fairly complicated. And I feel like this might be an example of where we can use technology to fight a court battle that we think is not just, but also maybe apply for grants, apply for scholarships, apply for job applications, for people maybe who need that kind of help or don't know how to do that because it's a fairly complicated thing. These types of uses, I think, will become more and more popular. On the same note, though, these two lawyers in Texas, I think it was, submitted a briefing that had that ChatGPT wrote for them, and ChatGPT had created some fake citations. That's because these models are meant to talk. They're meant to communicate to complete sentences and not really factual models. In this particular case, it just completed a sentence and said, hey, court motions need to have a citation of prior case law. And so I'm just going to make something up that looks right. And that's kind of what it did. The judge caught them. They got fined. They got in trouble. It was embarrassing and all that. So you need to be careful about how you use these models and verify their output. I am way over time, and I am sorry about that. What should we do, Sarah?
Yeah, so I think that we want to thank folks for being on the call. If you want to stick on, it sounds like Julio will be happy to stick around for a few more minutes and also take questions. If you've got questions and you want to put them in the chat, he can get back to you in writing as well. But yeah, if you want to take a few more minutes, Julio, and finish up, for anybody who wants to stay on, that's fine.
Okay, great. Thank you. And I'm happy to, I will give the slides, we can send the slides out. You can have a copy of the slides if you want.
Great,
So,
great. If you need to take off, thanks so much for being here, and you'll get a follow-up from me.
Okay, thank you. So we call these fake citations hallucinations. That's because it's not fact GPT, it's chat GPT. It's really trained and rewarded. It was meant to finish sentences, and so it's going to finish them even if it's got to make stuff up. One way to get around that is to do is what they're calling prompt engineering, which is to be very, very explicit about how you ask for things. Tell it to not make things up, tell it to state your assumptions and your limitations. Ask it to critique its answers. It'll improve answers over time. If you ask it to like, hey, can you make it more this? Is that really the best answer? Can you improve on that answer? And you can even a prompt will actually be longer. A good prompt will be much longer than you expect. It's kind of like you're really trying to give instructions to somebody who doesn't know exactly what you want, and so you need to tell them exactly what you want. And ChatGPT can help you with that. So a good prompt will be much longer than that. This is the idea. If you want it to, this is what the guy did with the zoning law regulations. He cut and pasted the zoning regulations into the prompt and said, what do I need to say to show that this is not a violation of this zoning regulation? And so then ChatGPT was able to read the rules and then say, okay, well, you fall within this category, or this is the exclusion you want, or whatever. And so you can cut and paste a bunch of information into a prompt and have it and ask it questions about that information. I did that with Claude. Claude has a really ability to take a bunch of text, and I did it with the BRCC General Education Assessment Report, and I just said summarize this document, and it goes and it tells me that that the graded CST 101 setting compared to low stakes did better than the low stakes graduation assessment. I don't know what any of that means. It told me that there were gaps noted based on ethnicity and Pell Grant eligibility. I don't know what any of that means. Hopefully that makes sense to you and that's accurate, and good and useful. And if you wanted to have it give you even better information, you need a better prompt than summarize this document. You might say, summarize this document as an educator who is looking for this kind of effect or whatever. And then that'll give you a much better answer than what I gave there. Another challenge is the data is not up to date. It was only trained, ChatGPT was trained up to data up to September 21. So you can't ask it for things that were very recent without doing this type of technique. There's always bias in the training data. And I don't mean just social and ethical or political bias, which there is all of that. But the thing is, it was trained on internet data, so it knows a lot about certain things, but doesn't know as much about other things. So you're a specialist in something, you probably know way more than it does, but it just knows about a lot of different things. There are copyright concerns, and that this is being worked out now in society and the courts, whether the system is just learning, whether that structural representation is just learning and fair use, or whether it's somehow copying the original material, and that's a whole nother can of worms. Security and privacy. Don't submit things that are private or any kind of personal information to these systems. Yeah, that's all I can say. These systems make things easier for people to create fake emails, documents, and so on. So be careful when using them. When you get a crazy email that looks well written and everything, but it's not, it seems fishy, be aware of that. People have been creating fake documents forever. It's just now a lot easier. Hopefully we'll create counter AIs that help you filter that out, much like the spam filters work now. Like I said, it's not a thinking machine, so it looks like it's thinking, but it's not. So you always need to be really keep an eye on its output. So conclusion, it's really good for search, especially for really weird questions that you're probably not going to get out of Google. It's really good for brainstorming, marketing, communications. You can ask it to do blurbs for a class, or do summaries, or blurbs for whatever you're doing, ads, headlines, things like that. If you can do some programming, it's great for automating summarization, classification, sentiment, all that stuff. You can ask it for advice on creating steps to achieve a particular goal, and then it's up to you to make sure that those steps really make sense and are really good. But it's a great place to start with those things. And so my recommendations is just experiment with the tools. You'll be amazed what they can do. Maybe some good things to do would be meeting transcriptions and summarizations, some brainstorming, simplifying and refining some language. If you write something like a job opening or a cover letter or whatever, just paste it in there and say, hey, make this better, and see what it suggests. That can be really useful. And find creative ways to use this in whatever your field is, whatever your job is. Be aware of the limitations, and then come up with good standard processes for how you want to use these things, and then help your institutions institute intelligent, good, useful procedures for this. And that's it. Thank you.
It was an unfair task, Julio. Let's all be clear that it's a lot to ask somebody to just explain AI to us in 30 minutes or less, right? So I do want to make time for questions. If you're on the call still and would like to answer questions or ask questions, feel free to throw them in the chat or unmute yourself. And I'm going to return to a gallery view so I can see who's still on the call. Does anybody have any questions they want to share out? Go for it, Joan.
Well, I was about to say, I have so many, I don't even know where to begin.
Yeah, it's a lot, right?
Yeah, it is. So in terms of using some of the features that you mentioned today, how do you go about determining, like, do they have reviews of the best chat? I don't know, what is the generic term? Chat GPT is actually a product name. I don't know what the generic term is. But how do you know, like, which is better than the other? You know what I mean?
Yeah. So I guess people, a more generic term might be LLM. That's kind of, not everybody uses that, but the Band-Aid term is ChatGPT. ChatGPT probably is the best general one. And then if you have very specific use cases, you might find another one that is better, like the Bloomberg GPT for financial information, or medical GPT for medical information. Somebody might have created something specific for your field, but ChatGPT is a good place to start.
Okay, so whatever field I'm interested in, like, then I would search education GPT.
Probably. I don't know that there's
Okay.
an open free one out there, but there probably is somebody that has created something like that. And I would know that it was trained specifically on education related material, or I'm not sure if you meant like research and academic stuff, or policy and procedure stuff, or legal, the legal aspects of education, or all those things. There's probably somebody that has trained a model just on that stuff, so you can ask it those kinds of questions. And that idea of pasting in a document and then asking questions about that document, that is super powerful. So ChatGPT lets you do that. So if you have a question about an educational policy or a document or a rule or something like that, you can paste that in there and ask questions about that, and that can be really useful.
That was my next question. I was like, can I upload stuff to it, or can it only download stuff to me, or regurgitate stuff to me?
Yeah, Claude was the one that was famous for letting you upload things. I think ChatGPT has recently done that, but I don't know if it's available to everybody. So it's kind of hard to keep track of everything, because everything changes every day, and then not everybody has the same plan, But if you can't do it, you can certainly cut and paste. If you can't upload a document, you probably will be able to soon. Yeah.
Well, thank you.
Sure.
Katie, I see you're still on the call. If you've got a question, feel free to share it. Okay, I'm gonna go ahead and stop recording.
Okay.